Hello friends, this is Jim with Science Talk. In this video I want to discuss kind of a continuation, but a little bit more of an updated information, if you will, on the melting of Antarctica's ice. Before I do so, I want to remind everyone to please share my videos, please share the work that I do, please subscribe to my channel, please hit the bell so that you know when I drop a video. I also ask that you please consider becoming a patron to support this work. You can go to patreon.com/Science Talk with Jim Massa. If you're already a patron, I thank you for your support and continued support. It's important that the work that scientists are doing, and I myself am a scientist, it's important that this work reaches a broader audience so people know what is happening to their planet. We all live on this little blue marble, and as Carl Sagan said, pale blue dot. And perhaps we can then pressure those that make policies to change policies. So I want to give you an update on the melting of Antarctica's ice. It's accelerating faster. That's kind of the nuts and bolts about it. The melting is speeding up. The speed of Antarctica's melting has begun to gather pace between 1992 and 2017, basically a 25-year period. The rate of loss of ice from West Antarctica has risen threefold, from 59 billion metric tons per year to 159 billion metric tons. The West Antarctic Peninsula, one of the fastest warming places on Earth, has seen ice loss increase dramatically from 7 billion to 33 billion tons a year in that same time span, as the ice shelves continue to collapse. Altogether, in those 25 years, Antarctica has lost more than a trillion with a T, tons of ice. Since the southern continent is the biggest store of fresh water on the planet, if it all melted, the sea levels would rise by 58 meters. All up, that means the entire ice sheet from the continent all the way to the interior, to the pole, and so on. If all that were melted, sea levels would rise 58 meters. What does this mean? It means that the melting in Antarctica alone has raised global sea levels by 8 millimeters as global average temperatures rise in response to ever higher levels of carbon dioxide in the atmosphere. Now 8 millimeters, that's 8/10 of a centimeter, so it's almost a centimeter, may not sound like much, but a centimeter is basically what, 2/5 of an inch? When you consider the entire surface of the Earth and how much of our surface is really covered by ocean, that is not an insignificant amount of water being added to the system. In fact, I have long thought that this planet was given the wrong name. It should be called Oceanus. But I digress. So if humans continue their burning of fossil fuel unabated, then by 2070, global sea levels will rise even faster by a meter, with 1/4 of that from Antarctic meltwater. And ever more ice will be lost from the Southern Ocean. Now, when you do all this, this will drive big changes in the marine ecosystems of the Antarctica. It may allow invasive species to colonize areas they could not before. Now, you may, if you have not already seen my videos on the Atlantic Meridional Overturn Circulation and the Conveyor Belt, please do check those out. In those videos, I discussed how adding the layer of fresh water, especially in the Jin Sea, this is on the other end, off of Greenland, can lead to a slowdown of formation of the North Atlantic deep water, if not an outright stoppage. Well, that of course is a heat distribution mechanism for the planet, and not only that, when it finally upwells in the Southern Ocean, it brings nutrients. Well, as I discussed in those videos, if you shut that down, you can collapse the ecosystem. Well, now, if you start adding fresh water, you're diluting the ocean surface, you can lead to stratification regimes where even if the conveyor belt was flowing, albeit at a slow down rate, if you have permanent stratification, you may not be able to get the required nutrients up into the photic zone. And that can cause problems for the ecosystem. I discussed in a video I talked about water mixing, where I kept my comments to fresh water, that basically, and this is true in the ocean, to have productivity in an aquatic system, you need some sort of a mixing event, followed by stratification, so that the phytoplanktons are kept within the photic zone, along with the nutrients, so they can do their primary productivity. And then the productivity will collapse because the nutrients are used up, and then you have a breakdown in the stratification, renewal of the vertical mixing, and so forth. Similar thing happens in the ocean, only it may not overturn all the way down thousands and thousands of meters, maybe the upper 200-300 meters, but still. And that is where most of the pelagic open water productivity takes place, is in the upper several hundred meters of the ocean. You get into the deep, deep depths, there's not much happening. Unless you're at a hydrothermal vent. So, there are implications for all this, that we can change productivity, we can change ecosystem, we can also start changing circulation patterns. Series of research papers in the journal Nature relates the ice loss and the global concerns that the authors, the researchers express. A team of 84 scientists from 44 international organizations have amalgamated 24 satellite surveys of change in the farthest south with greater precision than any study has done previously. Dr. Andrew Shepard, who is associated with the University of Leeds, same group in my previous videos, he states, according to our analysis, there has been a steep increase in ice losses from Antarctica during the last decade, and the continent is causing sea levels to rise faster today than at any time in the past 25 years. He also led the assessment, I should note. This has to be a concern for the governments we trust to protect our coastal cities and communities. Yeah, we haven't even talked about that. See, a lot of cities right on the coast. Sea levels rise, those cities may not become habitable. Then you have millions and millions of refugees. Now, I saw a clip, or I subjected myself to a clip of some non-scientist who gets paid by fossil fuel companies. He was basically, I think he was talking with Stuart Varney on Fox, which, well, that's a joke in and of itself. But he was basically saying, well, Antarctica ice has grown and shrunk, grown and shrunk, grown and shrunk. Yeah, it has. There's a thing called winter and summer. This ice is going to grow during the winter, and it's going to melt a bit in the summer. And yes, when you have warming and cooling of the planet overall, ice sheets will grow, ice sheets will shrink, and so on. But what many people fail to get, and this is a point I keep trying to stress, it is the rate of which, whether it be temperature increasing, the rate of how fast the ice is melting, it is the rate that is so much faster than that we see in any of the geological, cryogenic records, data that we've analyzed. The rate is much, much faster than what we see in the records, going back as far back as we can go. So, yes, there may be some variation due to natural cycles, of course. But when you juxtapose human activity, it is much, much faster. And when you account for human activity, when you remove the signal that is caused by natural variation, what you are left with is human activity. I've explained earlier that when we create models, regression models, linear, curvilinear, other more complicated models, that oftentimes you may have one variable explain 73% of the variation, but two variables will explain 98% of the variation. That's a decent model. We then have the two independent factors that determine the response. Well, when you look at natural variability, it explains about 23 to 27% of what we're seeing. The rest of it, the majority of it, some 73% or so, is due to human activity. Researchers have warned that warmer seas make faster melting inevitable, and that by 2050 the rate of loss could double. Using both direct observation and remote sensing, they have observed fresh water running off the polar surface in the summer and recorded the first signs of invasive plants on rocks that were once all but barren. Now data from the satellites launched by the European Space Agency, Japan, Canada, NASA, Italy, and Germany have been combined into something known as the Ice Sheet Mass Balance Intercomparison Exercise, or IMBE, if you want to make an acronym out of it. And it has answered one of the great uncertainties. Basically, it's provided a continent-wide picture. While the western Antarctic ice sheet has been steadily melting, there's been evidence that East Antarctica itself was stable or even growing, and the latest study settles an old argument as to what's going on. The combined evidence suggests that East Antarctica is more or less stable, gaining, if anything, 5 billion tons a year on average due to greater snowfall. Remember, warmer air holds more moisture. You're in a polar region, you hold more moisture. How's it going to precipitate out as? Snow. So again, these people say, oh, ice is growing over there. The warming is silly. Warmer air holds more moisture. Overall, though the continent is losing the mass of its ice and the world continues to warm, this loss will only accelerate. So going back to looking at the cycles and those who dispel, or not dispel, but disagree with what the scientists are finding, it's like, if I have, let's say I have a trend, I'm looking at temperature trend, and it goes up and then it drops, and it goes up a bit more and it drops, it goes up and drops. So basically you get this jagged line that does something like that. Well, I could fit a regression line through that, or use a Fourier smoothing procedure on it and then run a regression, what have you. I can perform valid statistical analyses on that, and I would note that, my example, I'm tracking temperature, and I would note that the slope of my line is positive. It means temperature overall is increasing. So what's the ups and downs? The increase in temperature, decrease in temperature. Well, seasonal variation, it's called weather. So the jagged line that goes up and down all over the place, that's weather. The regression line through it, that's climate. That shows the long-term trend. That's climate. Well, we can do the same thing. If we track, the volume of Antarctic ice, we might see it decreases, it goes up, it decreases, and so on, right? Same thing. I fit the regression line through that. I have a negative slope. Means I'm decreasing, means I'm losing ice. Really straightforward concepts. So, I'll end this discussion here with a quote from Martin Seegert, who is of the Grantham Institute at Imperial College London and an author on the study I've been sharing with you. He says, quote, "Unfortunately, we appear to be on a pathway to substantial ice sheet loss in the decades ahead, with longer-term consequences for enhanced sea level rise. Something that has been predicted in models for some time. If we are not already alert to the dangers posed by climate change, this should be an enormous wake-up call." He continues, "Antarctica is being affected by global warming, and unless we curtail our CO2 emissions within the next decade and have a zero carbon economy within a few decades, we will be locked into substantial global changes, including those in Antarctica and the Southern Ocean." So there you have it. Antarctica's rate of ice loss, I'll get it out eventually. Antarctica's rate of ice loss is increasing rapidly, losing more and more ice, as it is in Greenland. This will have consequences for marine ecosystem. It may have consequences for the conveyor belt, which is a heat distribution mechanism for the planet, bringing cold polar water to the tropics, warm tropical water to the pole. But it could change weather patterns, it can change ocean current patterns. Basically, the system has been perturbed, no longer in its equilibrium. So in its perturbated state, it is trying to find its new equilibrium level. But because the system keeps being perturbated, it becomes more and more difficult to find the new equilibrium level. So as a result, stay tuned for crazy, chaotic weather and with major changes to our climate. Thank you for your time. Please share. Please subscribe.